Welcome to the standardized patient simulation system. Before we begin the training session, gaze tracking calibration is critical to your gameplay experience. If these parameters are not properly adjusted, the system will not detect your gaze accurately. This can make in-game controls extremely difficult or may even prevent you from progressing through the scenario altogether. Please follow the upcoming steps patiently and thoroughly for an optimal and seamless simulation. Initializing system. If you prefer not to display your actual face, you may enable the Sensor Face option now. Adjust the transparency of the user interface background layer. Adjust the transparency of your foreground face layer overlaid on the system screen. Please look directly into the camera. Move your face as close to the camera as possible, ensuring that your entire face remains fully visible and framed on the screen. Now, manually adjust the W value to set the width of the bounding box to match your face. Next, manually adjust the H value to change the height of the bounding box until it securely frames your entire face. Then, adjust the Y offset to shift the entire bounding box up or down until it perfectly aligns with your actual vertical position. Starting distance evaluation. Please hold still and keep your face within the designated frame. Next, we will configure the eye blink detection system. Starting with the left eye. Please close your left eye only and observe the threshold value in the bottom left corner to see what it reads. When your eye is open, the status indicator will turn green, and when your eye is closed, the status indicator will turn red. Please adjust the threshold level until the system distinguishes between green and red clearly. Now for the right eye. Close your right eye only and observe the value in the bottom right corner in the same manner. Adjust the threshold value until the system reliably switches from green for open to red for closed. For the average Windows value, which determines the number of frames averaged for calculation, setting this too high will cause a delayed response, while setting it too low makes it overly sensitive. We highly recommend setting this value to 1 for the most real-time responsiveness. Now let open and close your eyes follow voice. Close your eye. Open your eye. 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 You should not exceed more than 2 errors. If you do, we recommend going back and readjusting the threshold values. Proceeding to the most vital phase, which is gaze capture. Please stay calm and take your time during this step as there is no need to rush. Use your eyes to look directly at the number displayed inside the red point on the screen. And while keeping your gaze on it, repeatedly press the spacebar. The number on the point will count down until it reaches 0, after which the system will automatically move to the next point. Continue doing this until you complete all 25 points for a total of 3 rounds. If you are ready, you may begin. Processing gaze architecture data. This calibration step may take a few moments. Please wait until the results are displayed. Results are ready. Your gaze precision is now plotted on a scatter point graph. Please verify that each colored cluster is tightly grouped together in its correct position. An ideal calibration should not show points scattered erratically to the extent that the colors become indistinguishable. You will now see a red circle tracking on the screen, which is where the gaze tracking system estimates you are looking. If it does not align perfectly with your actual gaze, do not panic. Try slightly shifting your head angle to find the right sweet spot. Next, select your preferred tracking model. For this setup, we highly recommend selecting linear regression. Adjusting the average gaze tracker value. If set too high, the tracking will be smooth but suffer from input lag. If set too low, the tracking circle will jitter and become overly sensitive. Setting this starting value to 10 is recommended for optimal stability. Adjusting the H-scaler to control the Y-axis for up and down motion. A higher value causes the circle to swing aggressively, while a lower value minimizes its movement. To test this, try looking at the absolute top and bottom edges of the screen to see if the red circle reaches the boundaries accordingly. Most importantly, after adjusting, look back at the center of the screen to ensure the circle returns precisely to the middle. Adjusting the W-scaler to control the X-axis for left and right motion. Similarly, a higher value amplifies the left-right swing, while a lower value restricts it. Test this by looking towards the absolute far left and far right edges of your screen to check if the circle tracks all the way. Do not forget to return your gaze back to the center of the screen to confirm the circle centers correctly. The final phase will be the gaze tracking performance evaluation. Green target points will randomly generate across the screen. Attempt to track and overlay the tracking circle onto these green targets within the given time limit. You should not miss more than 5 points. If your results are not satisfactory, you can fine-tune these parameters at any time in the settings menu and practice your accuracy within the playground mode.